NFPA 72, the National Fire Alarm and Signaling Code, addresses the installation of fire sprinkler heads in proximity to electrical equipment. Specifically, Section 4.14 5.4 1.4 states that fire sprinkler heads shall not be installed directly over major electrical equipment unless protected against damage or activation by the electrical equipment. NFPA 70, the National Electrical Code, also provides guidance on this matter. Section 110.11 states that electrical equipment shall be installed in a manner that does not create a fire hazard. Additionally, Section 409.21 requires that electrical equipment be installed so that it is not exposed to excessive heat from other sources. The interpretation of these codes suggests that fire sprinkler heads should not be installed directly over 4,160 volt switchgear unless precautions are taken to protect them from damage or activation by the electrical equipment. These precautions could include installing a heat shield between the sprinkler head and the switchgear, or using a sprinkler head designed to be resistant to heat and activation by electricity. In situations where a new switchgear has been installed under pre-existing sprinklers, it is likely that the sprinklers were not designed to be protected from damage or activation by the electrical equipment. Therefore, several actions are recommended. Firstly, consider installing heat shields between the sprinklers and the switchgear. This will provide a physical barrier to protect the sprinkler head from excessive heat generated by the electrical equipment. Secondly, evaluate the existing sprinklers and determine if they are suitable for the environment. If not, replace the sprinklers with ones that are resistant to heat and activation by electricity. These specialized sprinkler heads are designed to withstand higher temperatures and are less likely to be activated by electrical faults. Thirdly, conduct a comprehensive fire safety assessment to ensure that the overall fire protection system is still adequate. This assessment should take into account the presence of the new switchgear and the potential impact on the effectiveness of the existing fire suppression system. The purpose of these code requirements is to minimize the risk of accidental sprinkler activation due to electrical faults or excessive heat. An unplanned discharge of water onto electrical equipment can cause significant damage, create electrical hazards, and disrupt operations. By adhering to these codes and implementing appropriate protective measures, facilities can ensure the safety of personnel and equipment while maintaining adequate fire protection. When assessing an existing installation, it is essential to consider several factors. Firstly, the distance between the sprinkler head and the switchgear is crucial. The closer the sprinkler head is to the equipment, the greater the risk of activation due to heat or electrical faults. Secondly, the type of sprinkler head installed plays a significant role. Standard sprinkler heads are typically designed to activate at a specific temperature, while specialized heads may have higher activation temperatures or be designed to be resistant to electrical interference. Thirdly, the presence of any existing protective measures should be evaluated. Heat shields, for example, can significantly reduce the amount of heat that reaches the sprinkler head. Fourthly, the overall fire protection system should be assessed to ensure that it is adequate for the current occupancy and hazards. This assessment should consider the type of fire suppression system, spacing of sprinkler heads, and the water supply available. When selecting and installing heat shields, it is important to choose materials that are non-combustible and resistant to heat. The shields should be properly sized and positioned to effectively block heat from the switchgear. Additionally, the shields should be securely mounted to prevent them from falling or shifting. When replacing sprinkler heads, it is essential to select heads that are specifically designed for use near electrical equipment. These heads typically have higher activation temperatures and are less susceptible to false activations. It is also important to ensure that the new sprinkler heads are compatible with the existing fire suppression system. Fire safety assessment should be conducted by a qualified fire protection engineer or other knowledgeable professional. This assessment should identify any potential fire hazards and recommend appropriate mitigation measures. The assessment should also verify that the fire suppression system is properly designed and maintained. In addition to the code requirements and recommended actions, it is important to follow best practices for fire safety in electrical rooms. These practices include keeping the rooms clean and free of combustible materials, ensuring that electrical equipment is properly maintained, and providing adequate ventilation to prevent the buildup of heat. Regular inspections and maintenance of the fire suppression system are also essential to ensure that it is functioning properly. It is worth noting that the specific requirements for fire sprinkler systems may vary depending on local codes and regulations. Therefore, it is important to consult with local authorities and qualified professionals to ensure compliance with all applicable requirements. The considerations extend beyond simply placing a sprinkler head and hoping for the best. Understanding the nuances of electrical equipment, the potential for arcing faults, and the rapid heat rise that can occur is crucial. Without this understanding, even compliant installations may not provide adequate protection. Firstly, the type of switchgear itself matters. Air-insulated switchgear poses different risks than gas-insulated switchgear. Air-insulated switchgear can produce significant amounts of smoke and particulate matter during a fault, which could potentially obscure visibility and hinder fire suppression efforts. Gas-insulated switchgear, while generally safer in terms of fire risk, may still require specific considerations regarding the type of extinguishing agent used. Secondly, the location of the switchgear within the room is important. Switchgear located near doorways or other openings may require additional protection to prevent the spread of fire to other areas of the building. Switchgear located in confined spaces may require specialized ventilation systems to remove heat and smoke. Thirdly, the electrical protection scheme in place is crucial. Fast-acting overcurrent protection devices can minimize the duration of a fault and reduce the amount of heat generated. Differential protection schemes can detect faults within the switchgear itself and isolate the equipment quickly. Fourthly, the training of personnel is often overlooked. Employees who work with or around switchgear should be trained to recognize potential fire hazards and to respond appropriately in the event of a fire. This training should include the proper use of fire extinguishers and the procedures for evacuating the building. Regarding heat shields, the selection of materials is critical. Steel is a common choice due to its non-combustibility and ability to withstand high temperatures. However, the thickness of the steel must be sufficient to provide adequate thermal protection. Other materials, such as ceramic blankets or intumescent coatings, may also be used to enhance the performance of the heat shield. When installing heat shields, it is important to ensure that they are properly supported and that they do not interfere with the operation of the switchgear. The shield should be positioned to effectively block heat from the switchgear without obstructing access for maintenance or repairs. Regarding specialized sprinkler heads, there are several types available that are designed for use near electrical equipment. These include high-temperature sprinkler heads, which have a higher activation temperature than standard heads, and electrically isolated sprinkler heads, which are designed to prevent electrical current from flowing through the sprinkler system in the event of a fault. The selection of the appropriate type of sprinkler head will depend on the specific application and the level of risk involved. The fire safety assessment should also consider the potential for other hazards in the electrical room, such as flammable liquids or gases. If such hazards are present, additional fire protection measures may be required, such as explosion-proof equipment or automatic fire suppression systems. The assessment should also consider the impact of a fire on other critical systems in the building, such as emergency power systems or data centers. The goal is to ensure that the fire protection system is designed to protect not only the electrical equipment, but also the overall functionality of the building. Regular inspections of the fire sprinkler system should be conducted to verify that it is in good working order. These inspections should include checking the sprinkler heads for damage or obstructions, testing the alarm system, and verifying the water supply. Any deficiencies should be promptly corrected to ensure that the system is ready to respond in the event of a fire. Furthermore, it is critical to maintain accurate documentation of the fire protection system, including the design drawings, equipment specifications, and inspection reports. This documentation will be helpful for troubleshooting problems and for planning future upgrades or modifications to the system. The intent of these measures is to prevent the accidental discharge of water onto energized electrical equipment, which could result in serious injury or property damage. Water is a conductor of electricity, and if it comes into contact with energized equipment, it can create a short circuit, causing a fire, explosion, or electrocution hazard. By taking precautions to protect sprinkler heads from damage or activation, we can minimize the risk of such an event. Understanding the specific characteristics of 4160 volt switchgear is also important. This type of switchgear typically operates at a higher voltage than standard residential or commercial electrical equipment, which means that the potential for electrical arcing and heat generation is greater. Therefore, it is essential to take extra precautions to protect sprinkler heads from damage or activation in these environments. The NFPA 70 and NFPA 72 codes are not static documents. They are regularly updated to reflect new technologies, best practices, and lessons learned from past incidents. Therefore, it is important to stay informed about the latest changes to these codes and to ensure that your fire protection system is in compliance. Changes to the NEC and NFPA 72 happen on a 3-year cycle. Participating in industry training programs and attending conferences can help you stay up to date on the latest developments in fire protection. It's imperative to remember that code compliance is not a one-time event. It is an ongoing process that requires regular monitoring, maintenance, and updates. By taking a proactive approach to fire safety, facilities can ensure the safety of personnel and equipment and minimize the risk of fire-related incidents. Furthermore, collaboration between different trades and professionals is essential for ensuring effective fire protection. Electricians, fire protection engineers, building owners, and local authorities should work together to develop a comprehensive fire safety plan that addresses the specific needs of the facility. Open communication and a willingness to share information are key to achieving a safe and compliant environment. In addition to the technical aspects of fire protection, it is also important to consider the human element. Employees should be trained to recognize potential fire hazards and to report them to the appropriate personnel. Regular fire drills should be conducted to ensure that employees know how to evacuate the building safely in the event of a fire. A strong safety culture is essential for preventing fires and for minimizing the impact of fire-related incidents. Fire protection is a critical aspect of electrical safety, and it should be given the attention it deserves. By following the code requirements, implementing appropriate protective measures, and fostering a strong safety culture, facilities can create a safe and compliant environment for personnel and equipment. These measures collectively contribute to a safer working environment and reduce the risk of costly downtime or catastrophic events. Remember, the goal is not simply to meet the minimum requirements of the code but to provide the best possible protection against fire hazards.